All right, welcome to the Explainer. Today we're going to look at a fascinating test for AI. But here's the twist. It's not really about how smart the AI is, it's about us. It's about how patient we are when we're supposed to be its very first teacher.
You know, we're always talking about AI getting smarter and its algorithms getting more powerful. But what if we've been missing a huge piece of the puzzle? What if an AI success actually comes down to, well, us, how we react to it, especially that very first impression?
And that really is the million-dollar question, isn't it? Are we good teachers, or do we get frustrated when something's not perfect right away and just give up? Well, we're about to dive into a really clever study that put our teaching skills to the test.
Okay, so let's get into it. First things first, to really get what this experiment is about, you've got to understand the task they gave people. Just imagine you're the teacher, and your student is an AI that's trying to learn how to spot faces in pictures.
So here's how it worked. You'd see a bunch of blurry pictures, and in each one, there's a face. An AI, which was actually fake for the experiment, but we'll get to that, draws a blue box where it thinks the face is. Your job? Super simple. If the box is in the right spot, great, you just confirm it. If it's wrong, you just drag it to where it should be. The catch? You've only got 6 seconds for each picture. No pressure.
Now, this little task is actually a perfect example of a bigger idea called Explanatory Interactive Learning, or XIL for short. And it's a really powerful concept. It's all about letting everyday folks, people like you and me, teach an AI by correcting its reasoning, not just its final answer. In this case, you're literally showing it, hey, you should be looking here, which is how it gets smarter.
Okay, but this whole idea of us teaching AI runs into a classic human problem. You know what I'm talking about? First impressions.
Yeah, it really boils down to this, doesn't it? If an AI just completely botches its first few attempts, do you lose faith in it? Do you maybe get a little lazy with your corrections because deep down you've already written it off as a lost cause? Well, that is exactly what these researchers wanted to find out.
And there's a name for this in psychology, of course. It's called an order effect, but we all know it as the good old first impression bias. It's that funny thing our brain does where the very first bit of information we get about something totally shapes our opinion, way more than it probably should. And this bias can actually work in a couple of ways. You've got the primacy effect, which is when that first impression just sticks like glue. But then there's the recency effect, where it's actually the last thing you see that sways you the most. So the big question for the researchers was, which one is it going to be when we're dealing with an AI?
So, to get to the bottom of this, a team of researchers from the University of Trento in Italy came up with a really clever experiment designed to perfectly isolate this first impression bias. Here's what they did. They split everyone into 3 groups. Group 1 got an AI that was, well, pretty terrible at the beginning. It made most of its mistakes right away. Group 2 got the opposite, an AI that started out like a genius and then got worse over time. And the third group? They saw an AI whose mistakes were just sprinkled evenly throughout the whole task.
Now here's the really brilliant part of the setup. Everyone in every group saw the exact same 40 images and the exact same number of total mistakes from the AI. The only thing that was different was the order in which those mistakes happened. And to make sure it was a totally controlled experiment, the AI wasn't really learning on the fly. Its performance was all pre-programmed.
All right, so what do you think happened? When the researchers crunched all the numbers and looked at the feedback people gave, the results were, well, probably not what you'd expect.
And we're not talking about a small study here. They had a ton of people participate, which gives their findings some serious weight.
And this right here is the headline, the big takeaway from all 713 of those people. Just look at this chart showing how good the feedback was, how accurately people fixed the AI's mistakes. The bars for the bad start group, the good start group, and the steady group are practically identical. It just didn't matter how the AI started. People were just as good at teaching it no matter what.
So, get this. The first impression bias pretty much vanished. A bad start did not make people worse teachers. They stayed on task, they gave really good feedback, and it didn't matter if the AI seemed dumb at first or smart at first. That powerful bias we all have just wasn't a big factor here. So why is that? The researchers have a pretty cool theory. See, in one version of the experiment, they told people the AI model was being updated as they went, and they think that little piece of information is key. It suggests that we're actually pretty good at resetting our expectations, giving the AI a clean slate, as long as we believe it's actively trying to learn and get better. Okay, so what's the big picture here? What does all this mean for us? Well, it actually paints a really optimistic picture for how humans and AI are going to work together in the future.
The bottom line is, we're surprisingly good coaches. We don't seem to hold a grudge against an AI if it stumbles out of the gate, and that is huge. Think about it. It means we can build all sorts of amazing systems. Tools for doctors, assistants for artists, you name it. And they don't have to be perfect from day one. They can be launched, and we, the users, can actually help teach them and make them better.
And that just completely reframes the challenge, doesn't it? The goal isn't just to cook up some perfect, flawless AI in a secret lab anymore. The real goal is to build an AI that's a good student, one that's ready to learn from its partners out in the real world. And those partners, us, are, as this study shows, way more patient and effective teachers than we probably give ourselves credit for.
Which kind of leaves us with one last big provocative question to think about. If it turns out we're actually much better AI coaches than we thought, what are the most important things we should teach them next?